Good morning, good evening, wherever you are in your time zone. Welcome to another VMware Cloud Customer Success webinar. Today we have a good one for you. I should introduce myself as well, vCloud Matt, Matt Vandenbeld, and our Customer Success team. We have a good session for you today. Wavefront by VMware is a cloud-native monitoring and analytics platform used to alert on, troubleshoot, and optimize the performance of multi-cloud application environments. It delivers 3D observability by performing analytics on metrics, traces, and histograms gathered on distributed applications, application services, containers, and public private hybrid cloud infrastructures. Just a housekeeping note for those of you in Zoom, you are all muted. Please put your questions in the Q&A box and we'll address them as we go through. If you're watching on Twitch, feel free to post questions in the Twitch chat as well. If you're watching this on the recording on YouTube later, feel free to email us at cloudcs@vmware.com and we can get an answer back to you. With that, I'll introduce our speaker, Connor. Connor, if you wanted to kind of give a brief introduction of yourself and then head right into it.
Sure, thanks very much for the intro. My name is Conor Beverland. I'm part of the customer success team that focuses specifically on the Wavefront product that we're going to show you today. I've been with Wavefront in total for 4 years, both when it was a startup and now within VMware for the past 2 years. I'm hoping to show you mostly today a demonstration of the product, but I do have a few slides to kind of help set the scene and hopefully answer some questions that you may have up front. Kind of the first thing that I'd like to get into is just level setting, kind of why does a product like Wavefront exist in the first place? And some of this stuff may be kind of motherhood and apple pie to you, but I think it's useful to kind of think about how the world has changed and is continuing to change so rapidly when it comes to both how we deploy, write, and operate applications, and then, of course, how we monitor and observe and understand how those applications are behaving and performing. I think a big part of this is just the rapid rise of things like containers, microservices, and simply just the fact that oftentimes these days, services and apps are running across multiple different infrastructures, whether they be public clouds, private clouds, or some hybrid of those. And that has posed big challenges for traditional monitoring tools that often, even frankly, some modern ones, like take, for example, AWS CloudWatch, or any tool of that ilk that's very much focused on monitoring one specific environment. It may work pretty well if everything you have is running within that one particular environment, but if you have a pretty heterogeneous environment with lots of different pieces to it, you need a monitoring tool that can both scale to just monitor the sheer volume of things that you have going on, and also deal with the ephemerality of the modern architectures that apps are running on these days, particularly with things like containers, which oftentimes are spinning up and down extremely rapidly within minutes. This is really kind of hell for any monitoring system to deal with that change and still remain performant and scale well and so on. Another piece of this is just the kind of changing personas and kinds of teams that are working with data and working with monitoring applications. I think, and it's sort of the rise of DevOps and how that is becoming much more mainstream. A lot of the customers that use Wavefront today have already adopted a DevOps mindset in terms of how they write applications and operate them. And others are sort of starting that journey and moving along. And we're seeing that become more and more common. The kinds of teams and users then that use software like this demand both a lot of flexibility in terms of being able to send their own custom data to the tool. So that again can be a challenge for many monitoring systems that may be kind of fenced in around the kind of things they monitor and not let you go outside of those lines too much. But also in terms of just the functionality of the tool. And you'll see as I show you Wavefront today, the kind of powerful analytics and queries and questions that you can ask in a tool like this. And the DevOps teams that use products like this are demanding that kind of functionality. And finally, and we see this a lot in our customer base, I think this lack of unified visibility impacting the availability and the mean time to resolution, or frankly, just mean time to understanding what is causing a problem. I'm sure some of you may have been in these kind of firefights yourself. I know I have myself, where you know that something bad is happening, you know that your customers are being impacted, but you don't know exactly what's causing it. And you might have lots of different teams from different disciplines within your organization, maybe the networking team, maybe the infrastructure team, maybe the application developers themselves, all using their own siloed tools, all perhaps saying the problem's not in the network's fine, or the problem's not in the infrastructure's fine, and all kind of finger pointing. It's not to say that Wavefront replaces all those tools, like that Wavefront is not a network-specific tool with very network-focused capabilities in it. And in fact, I think any monitoring vendor that tries to tell you that they have one tool that will do absolutely everything for every environment and every scenario you have is probably kind of blowing smoke. But what Wavefront does provide is a common place where all of those teams can send some of their data and then speak a common language when they're working together to try and troubleshoot problems. Everyone's sharing links into Wavefront where you can see with evidence what's happening. If the network team feels that the issue is not in the network, they can show everybody why they think so by sending a link to Wavefront. And I'll show exactly how that works inside the tool itself. I do have a few more slides that I'll come back to later, but I thought I'd just jump into Wavefront to give you a bit of a flavor right up front of how it looks. The scenario here is, say I'm an on-call engineer and I've been paged or alerted by Wavefront to an ongoing issue. Wavefront might have notified me of that issue via Slack, maybe by an email, maybe through a system like PagerDuty or some other kind of paging mechanism. When it sent me the alert, it would have also given me some context about it, and the alert would have told me, go to this dashboard to try and diagnose this particular problem. When I jump into this dashboard, I can see the actual alert itself highlighted here. This is the thing that caused me to be paged in the first place. And it says, this is a severe alert. Our aggregate transaction rates or our overall transaction rates are too low. They've dropped by 10%. And sure enough, we can see that this total transaction rate has dropped off the cliff. It looks kind of bad. So let's try and figure out what's happening. As you're ingesting data into this system, you can give metadata to it. And once you have that metadata, it makes it very easy to pivot or slice and dice by that metadata. And I may initially do that to try and figure out where this problem is being isolated to. So if I pivot, first of all, by the customer tag, I'm trying to see here, is this a customer-specific problem? And I can see that no, it isn't. All of the different customers are all dropping off at the same time. Instead, it might be an app server-specific problem. And indeed, when I pivot by that dimension, just a single one of the app servers does indeed leap out. And I can actually see highlighted here for me that the app server in question, the one that has the problem, is app5. So this is pretty good. If I can be notified of an issue and this quickly drill in and know that the issue is coming from one particular app server, I'm already doing fairly well. But with Wavefront, I can go even deeper and try and diagnose what exactly is happening inside app5. To do that, I'm going to focus this dashboard on app5, and I'll direct your attention to this chart on the right. Now, this is kind of intentionally noisy. What we're displaying here is all of the metrics that we're collecting from app5, both from the infrastructure itself, like the actual machines that this is running on, but also the software, like the metrics from the actual code itself. And of course, one of those metrics is the transaction count, the thing which is causing the alert to fire in the first place. So there's that transaction count there. And what I can also do then, this is one of the really powerful and unique things that Wavefront can do is I can correlate across all those metrics, whether it be hundreds or even thousands of different metrics, to see while this transaction rate is dropping, what else similar was happening at the same time. This may help me narrow down to what's causing this problem. And when I do that, it's highlighted for me that at the same time as the transaction rate was dropping, free memory was also dropping. So this seems to be an issue to do with lack of memory. And I can also see some inverse correlations. So as well as some things that are positively correlated, I can see that the rate of errors spiked up. Okay, perhaps that's not too surprising. And also the rate of garbage collection spiked up. So this was an issue due to a lack of free memory and exacerbated by frequent garbage collections going on. Now that I know that, I can hop on to F5 and remediate the issue. Maybe all it takes is a service restart. Maybe I need to give that machine more memory. And in fact, if it turns out that this is a repeatable thing that I can automate, the next time I can actually have the Wavefront alert just run an automated nurse job to fix the problem for me without me even having to do any diagnosis and troubleshooting like this. So I hope that gave you a useful flavor of what Wavefront's all about. I'll jump back in to the presentation here, but I'll be flipping back to a demo shortly and showing you more about how Wavefront works. So you've kind of seen a little of it, but what is Wavefront? It's essentially a metrics monitoring as a service product. So Wavefront is a service that VMware hosts for you. You send your data to it. We keep that data for you and let you visualize it, do analytics over it, alert over it, and so on. Although we run in the cloud, we're agnostic to where customer data comes from. So across our customer base, we probably have about a 50-50 mix of customers that are running on-prem versus those that are running in public clouds or some kind of hybrid style. So we run the service in the cloud, but you can send data to it from wherever. Some of the larger organizations that are using this, companies that you may have heard of, like some of really the largest SaaS companies or the largest websites in the world, like Workday, Reddit. And in fact, if some of you are existing users of the VMware on AWS service, you might be interested to know that that team inside VMware, the VMC team, is actually using Wavefront to monitor all of the SDDCs that are provisioned within the VMware on AWS service. So we've seen a lot of adoption of this technology, both outside of VMware, but also inside VMware as we've come into the company. I think it's kind of useful to highlight just what metrics is. So we kind of talk about Wavefront being this metrics monitoring tool. What are metrics? We've kind of seen some already. That transaction count is an example of a metric. One of the really nice things about metrics and then a tool like Wavefront that exposes metrics is they're actually just really, really simple. We can see some CPU metrics on this chart here. This is just an example. There's several machines here reporting their CPU utilization percentage. And here's how that data would actually be represented and sent into Wavefront. If you're using one of the many out-of-the-box integrations, some of which I'll show you in the demo a little later, you don't even need to know about this data format. But should you ever have a desire to send some totally custom data into the system, it's very easy to do so. The data format is literally a simple line-orientated format. You send one or more lines of data formatted this way, and then that data will show up in Wavefront. Typically will appear in your charts in Wavefront within about 1 to 2 seconds of you emitting the data. So it allows you to send huge amounts of data points like this. Some of our customers are sending us well in excess of 1 million data points every second, and have that data appear in Wavefront really quickly. We then keep that data at the original resolution that you sent it for 18 months, allowing you to compare, especially if you have seasonal businesses, compare how your system is behaving today versus last year, last time you had that big seasonal spike, with the original fidelity of the data that you sent. The format itself is simply the metric name, the thing you're measuring. In this example, it happens to be CPU.usage, but it can be anything you like. In fact, we have a customer who has a heart monitor service, and they're sending the patient's heartbeat data into Wavefront, just naming the metric appropriately.
Yeah,
You
just
have
just to touch on that real quick too. Not as cool as a heart rate thing, but as part of our CTOA CTO Ambassador program, one of the cool things that we did was kind of a hackathon around Wavefront, where they gave us Raspberry Pis and a temperature sensor, and we were able to get that temperature reading into Wavefront and be able to display it and stuff, which was really kind of cool. So the extensibility is definitely there.
Yeah, that's a neat use case too. Very nice. So you have the measurement. Again, that could be temperature, like Matt just said. The value at the point in time you took the measurement, the timestamp at the point you took the measurement. The time is always just Unix epoch seconds. If you've never seen this before, it's a pretty common way of tracking time, which represents the number of seconds elapsed since Jan 1st, 1970 in UTC. The nice thing about it is it's then time zone agnostic. This timestamp is the same in wherever location you are in the world. We always have at least one tag on the data that we call the source. This is the thing that is emitting the measurement. It's very often a host name, but it doesn't have to be. It could be a database. It could be the name of a service, what have you. Then you can optionally have any number of additional key value pairs that you want to give additional metadata to this. In this example, we just have one saying environment equals prod. In the demo I showed you previously, there were a couple of tags that allowed us to pivot by customer or by app server. And you can have as many of these as you like. So the cool thing about it is it's a very powerful system, but just so easy to get data into it. I think it's useful to kind of look at where does a tool like this fit into a kind of a common modern monitoring stack that we see in our customer base. I don't know if this is something that you've seen before, but this kind of 3 pillars of observability concept, which is highlighted and depicted in this slide here, is becoming a pretty common thing across the industry. And what you normally see is people talking about metrics, logs, and APM or traces. And I think there's a nice analogy here to how these different kinds of tools can be used for different things, and harkening it back to how an aircraft might be monitored. Wavefront is primarily a metrics tool, although actually we today now support distributed tracing as well, which I'll touch on when we get there. But traditionally, historically, Wavefront has been a metrics tool. And these are really, metrics are the kind of the first thing you look at in a system like this. They show you what's happening right now. They show you continuous trends of behavior over time. They're very, very good for alerting over, and they're very, very good for quickly slicing and dicing to understand where the problem may lie. Logs are quite different, and if you use tools like Log Intelligence from VMware or Splunk or Elk, these are some of the common ones out there. These are very different systems. Instead of measuring continuous metrics, log systems measure individual events, like this error occurred at this point in time, and it may have a huge volume of data with it, like even a stack trace or something like that. They are very good for understanding deep detail of why something happened, but they're not as fast as metrics. So in this analogy, they're kind of like the metrics is what the pilot's using as he or she is flying the plane, and the logs is what the crash investigator would use when they dig into the black box. Then the APM tools then give you, and it's kind of depicted here in this diagram, APM tools give you the context of the connections between the components in an application and context of individual transactions that live within that application. And the analogy here is that this is very good for looking for bottlenecks and also for digging into details after an incident to produce something like a detailed root cause analysis. There's kind of like a little summary here of the pluses and minuses of these things. Metrics are small and fast. You can look at huge amount of metrics really quickly, especially in a tool like Wavefront, which is the industry-leading metrics tool when it comes to speed and scalability. Logs do have their uses, but they're slower to use, and keeping that voluminous data is very expensive. And then traditionally, at least, I'll touch on how Wavefront has approached this problem. Traditionally, APM tools have been very expensive. That's been kind of the biggest bottleneck to their adoption. I've heard of numerous times where customers of APM tools will only monitor a small subset of their applications because it's too expensive to monitor everything. As microservices have become more and more prevalent, the industry has started to move towards something called distributed tracing. You may have seen or may already be using open tracing or open census-based tracing frameworks in tools like Jaeger. In 2019, Wavefront has released a distributed tracing feature within the product. This is really cool. It gives, Wavefront then becomes more of a complete observability platform. You've still got the metrics, which is kind of like the first pane of glass, the traditional thing that Wavefront's always been so strong in, but we now have distributed tracing as well, covering kind of two of the three main pillars of observability. And I'll give you a look at how that looks inside Wavefront in a moment. Just before getting into the demo then, I want to show you how you typically get data into the tool. It usually comes in one of three ways, or actually often a mix of these three. If you're using a cloud service, like say AWS, you can get data directly from that service. There are integrations within Wavefront where you just plug in the correct credentials, read-only, of course, for Wavefront to be able to pull that data out of your cloud provider, and then Wavefront just does it all for you. You don't have to install anything, configure anything, it just works. If you are using either software components that you didn't write yourself, like MySQL, Tomcat, Apache, or indeed just infrastructure, whether that be vSphere, machines, what have you, storage, we have agents with hundreds of out-of-the-box integrations for getting data out of those tools and into Wavefront. And then finally, if you want to understand exactly what's happening within your application itself, Wavefront comes with SDKs for all of the common, most popular languages for getting code-level instrumentation out of your app. And that's often where business metrics come in as well. That the applications you're writing is where your business logic resides. And so from those, you can emit both technical telemetry and business telemetry. Most of the time, at least in production, this data is flowing through what we call a Wavefront proxy. This is something that you would run in your environment. It provides a nice queuing point. If there's any network issue between your site and the Wavefront service, the proxy can just queue that data up and then flow it over to Wavefront when the network comes back. But should you wish to, you can, of course, just directly send the data into Wavefront without going through a proxy.
Then, just a quick question there, Connor.
I don't know if there are questions.
Well, I had just a quick question, actually. That proxy, that's just like a appliance kind of deployed into the environment?
Yes, it's a very simple little program. There's a number of ways you can deploy it. Recently, and I alluded to this earlier, how containers are becoming more and more popular. A lot of our customers are running it in a container, and we provide, we host a Docker image to do that. I think actually somebody has created an OVA as well for deploying it in vSphere environments. But it's actually, it's so simple, you may not even need that. There is just a simple one-line installer like run this one command and it'll install it for you. It only takes a few minutes. And you can do that on any VM, whether it be Linux, Windows, or even like Mac if you want to try it on your laptop.
Yeah, for when I hooked this up to our VMware Cloud on AWS instance, I just used one of our lightweight Linux provisions ones that VMware comes out with. So yeah, it was pretty simple. Even I could do it, so
Okay,
that's a good sign.
cool. All right, so I'm going to highlight a few things in Wavefront, and I think a good place to start, and we've just been touching on it, is integrations. So within the product, there is a integrations link right in the top menu, and you can see here kind of the breadth of stuff that comes out of the box. Like I said earlier, these are things that you don't even need to know that simple data format. If you're using any of these tools, you can get data out of them, usually in minutes, and it comes with dashboards and content pre-built for you. It's very easy to build your own dashboards in Wavefront, but it's always nice if you have a starting point and have some dashboards to start with.
Yeah, I saw you briefly show it, but there is a Tesla plugin, and I do know somebody that has plugged their car into it. So
yeah, that's right. Actually, not sure if that's yeah. So I'm looking at a demo environment here where nobody is sending data from their Tesla into this environment. But yeah, that's pretty cool and pretty easy to get.
yeah, I wouldn't want anybody I work with to know how I drive either. So that's probably why.
Back when Wavefront was a startup, we had an integration set up coming off one of the main investors' Teslas, and we had an alert set up that would notify us if that Tesla came within 2 miles of the office. So we were always ready if the investor showed up.
Well, that's fantastic. Cool.
Just by way of example, I'm going to take a look at vSphere, and there is some data flowing into this demo environment from vSphere. This could also perhaps be a good way of just showing kind of how these integrations work in general. There's usually an overview page giving you some kind of information about what to expect from this integration. Setup instructions, usually pretty simple, usually revolving around a popular and actually really nice open source agent called Telegraph. Telegraph has loads of plugins that come with it. Actually, it's got even more plugins than we have built pre-built dashboards around. And it's got a lot of traction as well. So, and as VMware, we're contributing back to it with things like the vSphere plugin. You can take a look at all the metrics coming off the integration. And you can see, for instance, for this particular cluster that we're looking at here, there's about 150 data points per second coming off this thing. And then for all of these integrations, you're going to get one or more dashboards. And in the case of vSphere, you get several dashboards out of the box. I'm going to click into the summary one just to take a look. And this is giving us a nice overview of everything that's going on with these vCenters. I'll just scroll through so you can take a look. The other nice thing it has is at the top here, it's giving me the ability to drill in to the other dashboards. So if I want to see, for instance, the detail of one of these 126 VMs that are in this vCenter, I can just click that dashboard to drill into it. At the top, I can pick whatever VM I'm interested in. And then there's lots here, right? There's 126. Let's actually switch cluster to see if we can filter this down a bit. When I pick one of the, oh, sorry, let's go to data center. When I pick a different data center, I get a filtered list of the VMs just within that data center. And in this case, there's only one. One of the really, I mean, it's so simple, but I think it's one of the most powerful things about Wavefront is just how fast it is. So I'm zooming out of this chart, and I'm now looking at several months worth of data from this VM. Whenever you manipulate data, whether it be zooming out, zooming in, it's very easy to then sync the entire dashboard on that time frame. So I'm now synced all of the charts on this dashboard to look at this several months worth of data from this VM. And you can see that in seconds, I can look at a huge time range of data. Wavefront has lots of powerful capabilities, like I showed in that earlier demo, how we can do really cool things like correlating across metrics. There's AI capabilities. And all that's really great and really unique and powerful. But frankly, sometimes the most useful thing is just throw a ton of data at it, look at that data over a long time period really quickly, and just visually quickly see the trends and things that are going on. In fact, it looks like it's just over 3 months of data that we're looking at here. I mentioned earlier how it makes it easy to get people on the same page. Like if there was something of interest or some problem with this, like maybe this time period is kind of funky, I can grab a link to that and I can share this with anyone. I can put this in a bug report, I can send it on Slack, and it will get whoever clicks the link onto the same page as me, seeing the same stuff that I'm looking at the same time period that I'm looking at it in.
I gotta say that's really cool. I'm sorry that would have saved me so much grief back when I was a system admin.
Yes, and sometimes, like I said, sometimes the simplest stuff is the most useful. Like the way this works is dead simple. And actually, for anyone that's building applications, I think this is a great pattern to copy and do the same thing. All of the context about what you're looking at is just encoded in the URL. So then you can just have a short link to that URL, and that will get you back to that same content at any time. Very simple, but very powerful. We've been doing a lot of work lately on our AWS integration, and I thought that would be interesting to show. So the previous one, the vSphere integration, that's actually how you would get access to your data if you were using VMware on AWS. This AWS integration is for if you're using native AWS services. So you can get from this all of the data that you have in CloudWatch, some additional metrics too. So we actually, by calling other AWS APIs besides CloudWatch, we get some additional data from AWS that CloudWatch doesn't provide. And for anyone that's not familiar, CloudWatch is AWS's monitoring service. So you get information about your instances and any services that you use.
So we just had so Connor, we just had a question pop in, and I think you kind of answered it. But the question was from Hong: am I able to use Wavefront to monitor VM host performance on VMC SDC? Yes. Right?
Yes.
It's just like vSphere.
This vSphere integration that I showed, you can point this at VMC and get the data out. And it's kind of interesting, like the VMC team themselves is also using Wavefront to look at that same data. But that's for their internal use of running the service.
And like I said, I had configured it as well. I showed it off on one of our office hours a little while ago. I mean, it's, as much as we kind of like to make VMC on AWS into a kind of a really big thing, and it is. There's a managed service offering and stuff around it, but at the core, it's vSphere, right? So those vSphere dashboards will apply to it. However, I do want to put in a feature request for that spinning globe on our VMware Cloud on AWS page as well. So
that would be neat.
Yeah. I don't know who I would talk to about that, but yeah.
Yeah, good idea. So this is a linked set of dashboards around AWS data that we recently developed. Pretty cool, so I'll show a few things that it has. The spinning globe is one of the cool things. In this particular AWS account that I'm looking at, there were 3 regions, but of course there are more regions than that around the world of AWS. When I drill into a particular region, I get this really nice node map of what's going on. And actually, I'm going to switch this to look at CPU utilization.
Just a quick question for my own edification here. So is this Wavefront built view, or is this like this is coming from AWS in any way, shape, or this is?
View is Wavefront, but the data is coming from AWS.
Okay, yeah, so, I definitely need to put in a future request to pretty up the VMware Cloud stuff. I'll talk with you later.
Yeah. Yeah, okay, sounds good. Yeah, through AWS does provide its own user interface for CloudWatch, so you can look at CloudWatch data inside the AWS console, but it also provides APIs for pulling that data out of CloudWatch and into other tools. And we see that a lot. Like, it's sort of something I mentioned in I think the opening slide. Like, CloudWatch may be good if all of your data is in CloudWatch, if everything you're doing is AWS, but that's rarely the case. You normally have some of your own custom data, or you have some stuff on AWS, some stuff on VMC, some stuff in your own data center. And it's really good to have a tool that can pull it all together. This node map, you can actually pick what metric you want it to look at. I've said look at CPU utilization. I can see that like this one is green, it doesn't have much CPU going on. The red one is got very high CPU utilization, which is pretty neat. You can group this by different things. So like if I group this by role, I can see how this gets linked out by tag, and I can drill into it. So if I wanted to see the details of this instance that has the high CPU, I can do that and see much more detail about what's going on. The other nice thing that this new dashboard framework does is it's maintaining a kind of linked trail of how I got here. So if I wanted to go back to the top level globe, I can do that. I wanted to briefly show, and we'll see kind of where we go with the time in terms of how many examples I show, but I wanted to kind of show a little of how these charts work under the covers. So far we've been looking at dashboards, which are essentially just groups of charts, groups of useful charts together, and very easy to make your own dashboards as well as using the out-of-the-box ones. Underlying all dashboards, and indeed all alerts, as we'll see, are charts. And this is an example chart, which I like to kind of show a typical use case that someone might use Wavefront for. In this case, we're just monitoring, on this chart at least, we're just monitoring CPU data. So we're looking at CPU load average across a bunch of reporting things. These could be VMs, or they could be Amazon EC2 instances, or anything else. And we actually have also marked here an event where we did a code change. You can integrate Wavefront with your deployment tool of choice, whether even VMware tools like VRA or whatever you happen to be using, and you can inject these kind of events, which can give really good context into why the time series is behaving the way it is. And perhaps I am an SRE or someone responsible for the performance of this system, and I might be told that a deployment is happening. And when I look at it, I can see, I mean, it's kind of noisy, right? Like the data's spiking up and down a lot, but it does look like there's this upward trend in the CPU load that happens after the code deploy. Now, I could, even from here, I could maybe grab a link to this, file a ticket and say, look, the CPU increased, but it's a bit unclear. Like it is so spiky and noisy. I can do a little more with Wavefront first to be a little more sure of myself. Wavefront has a query language for manipulating this data. And once you get used to it, I would say, at least for myself, I mostly just type the language directly. And I find that very quick and easy. It auto-completes for you and so on. But especially when you're learning the language, we provide a really nice query builder to explore the different functions that are available and play with the data. In this case, what I'm going to do is just simply average all this data. I've got a bunch of reporting machines here, and I just want to know what is their average, what's going on in general. And when I do that, it makes it even that much clearer that right at the point we did that code deploy, CPU load quickly shot up. Now, I think this is probably enough to be fairly certain that the code deploy is the thing that caused this change, but I might want to compare that just to be sure. It's very easy to compare your data at any point in time in Wavefront to what happened historically. There's a function called lag. In fact, there is a short link to do this from the dashboard itself. You can just compare, but I'll show how the function works. When I lag data, I can say by how long I want to lag it. Here I've said 1D for day, but I can specify seconds, minutes, hours, days, or even weeks. So very easy here. If I wanted to compare what's going on now to last year, I just lag by 52W, and that would give me the 1 year lag. Here I've lagged it by a day. I just want to see, okay, so this load average increased at the time of the code deploy, but maybe that's a daily occurrence. Like maybe there's some kind of backup job or something that happens at this time every day that would cause the load to increase. But I can see that's not the case, right? Like, in fact, I'll even label this. I'm going to name this query yesterday to label it. I can see that yesterday and today, we had a similar steady state behavior before the code deploy. Yesterday, that steady state behavior continued throughout the night, but today it did not. Today, the thing increased. So now I'm very confident this code deploy made the change. Finally, going back to my original issue, which is I want to tell somebody about this, and I want to give them some precise data about what exactly happened so that they get the urgency and they can go fix it. Once I have metrics in Wavefront, very, very easy to create new metrics out of them. I'm comparing today's CPU load over yesterday's CPU load. And when I do that, I can see that this caused approximately a 35% increase in CPU load. So now I can grab the link to this data, file a ticket for the engineers that push this code out, and be specific. This code deploy caused a 35% increase in CPU load. Here's the evidence for that. Please fix it. So kind of simple, but I think pretty powerful.
No, I'm sorry. I'm just sitting here, mouth agape because, again, when I was back as a system admin or coder, I mean, this would have been amazing to be able to compete, easily compare yesterday to today, or or an hour ago to today to highlight this out and then send a link to somebody would have just, I mean,
Yeah.
this to me is just fantastic.
This does kind of beg the question, like, I like the example. I use it in demos a lot, but it's sort of like, okay, why did I have to manually investigate this? Why couldn't the system just tell me that the CPU load increased too much? And certainly alerting like that is a big part of what Wavefront does. And I'll use a slightly different example to highlight it. It's one that actually came up from a customer ticket a long time back, but it was a cool example, and so we've often used it as a highlight of how alerting works. We're not looking at the real customer data here, but we're looking at a sort of representative example of what happened. What they were looking at was the total request rate into their system. They're actually one of the bigger SaaS companies around. And you can see that over the course of the evening and early morning, they had a fairly steady request rate for the most part. It was around 170,000 requests per second. There are these big spikes down, right? And initially these spikes may look alarming, but the challenge that the customer brought to us was that they didn't actually care about the spikes. They were so short-lived and so transient that it wasn't an issue. However, what you can see is during the course of the day, as people came into the office, the request rate into the service grew, reached about 280K, and then it had this sustained dip. It's not as large as the big spikes, but this sustained dip was a real problem. And they wanted to be alerted to this. And what they wanted to avoid was that classic alert fatigue scenario. Sounds like, Matt, you've probably been there in your past roles where the thing is constantly alerting you that something's wrong, but there actually isn't anything wrong, where there's nothing that you can do about it. Eventually, it just becomes noise, and you ignore the real problem when it occurs.
Yeah, you set up the email filter to just delete the alert.
Yes, exactly. There's a number of ways that you could approach this in Wavefront, but pretty simple and cool way. And actually, I could do this with the query builder like I showed earlier, but I'm just going to type it out. And as I said, once you've learned the language, it's very quick and easy to type things. I find I use that mostly myself. What I just did was take a 10-minute moving median of this same data. This is like a sliding 10-minute window of the middle value. That's the orange line. And what you can see is it very neatly captures what the customer considered their kind of actual data to be. Those scary looking spikes are completely gone, but the original issue, which was the thing they wanted to catch, is still there. Now we can look at how we would actually detect that and alert over it. The cool thing about alerts in Wavefront is that they just use this same query language. A lot of systems have different way, one way that you visualize data, one way that you alert over the data. Those two things often don't mesh together very well, and you have to learn two different paradigms depending on the situation. In Wavefront, we just unified these things together. There's one way of manipulating the data that drives both visualization of the data and alerting over the data. I'm going to name this query median, and I'm going to turn off the data, the original data. I'm going to do something actually very similar to what I did before with the lag. There's lots of ways you could approach this. In fact, at this point, Wavefront actually has automated AI built into it. So you can just ask Wavefront to tell you when it sees something that appears anomalous. But I'll look at this in the traditional way. And this is kind of, again, simple but cool, I think. What I'm doing here is I'm dividing the current median by what it was doing 10 minutes previously. And I'm multiplying it by 100 to turn it into a percentage. What this is now showing me is the percentage change of this data in a sliding 10-minute window. And I can see that, in fact, let me overlay the original data here. What I can see is even though the request rate was growing steadily during the day, in any given 10 minutes, as a percentage, it didn't change all that much, by only a few percent here and there. However, when the bad thing happened, I can see that it dropped by more than 10%. And if I want to alert over this, all I need to do then is simply say, tell me when this thing dropped by 10% or more. Oh, 90, not 0.9, sorry. And when I introduce a Boolean into my query, it changes the chart from the original data to just a 0 or a 1, depending on whether the condition is met. And I can see that at this point of the chart, it's a 1 because the condition holds true. And that's what will drive alerts. Then with alerts, I can have them send me, well, you mentioned email, Matt. I can have them send a simple email. I can have them page to a tool like PagerDuty, or via webhooks, really integrate with anything. Send a Slack notification, run an automated job to fix the problem, or anything under the sun. Anytime I'm looking at data, it's very easy to just alert over it. If I want, I've played with this, I've got the alert condition defined. All I would need to do is click the create alert link, and that would persist this as an alert in the system. I guess with about 10 minutes left, one thing I definitely want to give you a quick look at, and then depending on time, we can show other things. But I would definitely like you to see this distributed tracing feature that we built into the product. And this may be something that you haven't seen before, Matt. There's now this applications tab. If you're using any of the Wavefront SDKs to instrument your code and get them to emit traces, you'll see the services that you've defined automatically start appearing here. And the particular application that I'm going to look at is one called Beach Shirts. This is kind of a demo application around ordering and printing t-shirts. And I know the starting point of this service is the shopping, or the starting point of this application is the shopping service. So I'm going to drill into the shopping service to take a look. Now, this service is built on a few common frameworks: Jersey, gRPC, and Dropwizard. Not sure if you're familiar with these, but they're well-known and popular Java frameworks for building microservices applications. Cool thing about it is you drop in the Wavefront SDK into an app that's built on top of those tools. you need less than 10 lines of code. You don't have to do any custom instrumentation whatsoever, and you'll get all of this data out of the box. I can see what we call red data, R for the request rate of all of the services, or all the operations within this service, the error rate for those things, and the durations, the 95th percentile of how long these things were taking. I can also see a bunch of stats, or I should be able to see a bunch of stats from the components of the service. Oh, here we go. Like Drop Wizard or the JVM itself. If I look at this, I can see that there's regular peaks in the traffic here. If I drill into this, I can see that, actually I'll sync this to all the other charts. I can see that the service that is taking the longest time is this one called Order Shirts. And indeed, that same service is also the one that's causing the most errors. If I drill into the Order Shirts service, I can see all the traces of how this particular service invoked other services and how long each of them took. I also get this dynamically generated map of how this microservices-based application is fitting together, beginning with the shopping service, as I said, but calling others like styling, delivery, and so on. If I click any of these, I get to see the associated red data for any of those services that I click. And looking at these traces, I'll maybe check a few of them to confirm they're all similar, which they are. It's actually not the shopping service itself which is taking so long. The shopping service calls others, and the thing which is taking the most time is this gift wrap operation within the packaging service. This is pretty cool, like to be able to look at this is a relatively simple microservice app, although that said, there are still, even in this simple case, 5 services involved. But to be able to go from the top end that a customer is having a poor response time and see which particular service and which particular operation within that service is causing the problem within a few seconds is pretty cool. Within traces, a lot of context. So you can give arbitrary data in here about the actual particular request, which could be helpful in troubleshooting it. And from here, I can also quickly jump into that overall dashboard of this particular packaging service that's causing the issue. And I guess I will pause there to see if there's any other questions.
I haven't seen any come in. I think this is really fantastic. I mean, this will definitely help for root cause analysis or just even on the flow troubleshooting as opposed to reading through logs and all the other stuff that needs to go in to try to figure out exactly which component is going wrong. But I think if there's something else you wanted to kind of demo, I think you have absolutely some time to go ahead and do that.
I'll show perhaps one or perhaps 2 quick things. The first is that I'll show an actual example of creating an alert. I showed one over some historic data, but I didn't actually look into the alert dialog itself. So I'll quickly show that. Whenever I click alerts at the top here, I see a few things. I actually see there's one, this is just a demo environment, but there is one currently firing alert in this environment. And that's why I had this one highlighted the whole time. Within this interface, I can quickly slice and dice to look for different kinds of alerts. I can tag alerts, tag them by team and so on. Alerts, actually, this is very similar to the dashboard browser. So if you look, all these same concepts apply to dashboards as well as alerts. If alerts are being modified, version histories are kept. So it's easy to see who made what changes when. There's also a concept of maintenance windows. So if I know that I'm going to be doing some work on a particular set of hosts or a particular set of services, I can stop or suppress the alerts from firing for those things during the course of my work. And it's also from here where I can create an alert. And I'll just make a very simple one up to show you how this looks. I'm going to look at some data that we have here on request latency. I'm just going to ask for the biggest request latency in a 10-minute window. I can see that data here. I'm also going to try, I could do a simple alert like this. This will give me like one condition. And the cool thing about this though is it backtests it for me. Like I can see when would Wavefront fire an alert based on this condition. I can see, is this catching the kind of things that I care about, or is it too noisy? This takes a huge amount of the guesswork out of alerting. A lot of the times what you end up doing is you had an issue, you define an alert to catch that issue the next time, and then you just see in practice, does that alert catch the issue next time in reality? Does it actually catch way too much stuff that you don't care about, and is it too noisy? With Wavefront, if you have some historic data, you can play around with it. You set up a threshold, you play around with an alert to catch that thing, and you just see how frequently did it fire, or is it too noisy, or is it good? You can also have multiple different thresholds. So I can say, if it's above 250 milliseconds, I want this to be a severe warning. If it's above 240, I want it to be a warning. And I can have these things go to different places. Like I can have the severe one go to a pager duty to page the on-call person to action this immediately. I can have the warning one go perhaps to a Slack channel where maybe someone will take a look at some point, but it's not as urgent. And the last thing I'll leave you with, and it's something that I have touched on in one of the previous demos, but not as wide of time range as this, is just the kind of just raw scale that Wavefront can work at. What I'm looking at here is not much data in terms of the number of time series that I'm looking at. I'm mostly looking at just CPU load average from 2 hosts, although there's this period in time where there was a whole bunch of them. The cool thing is I'm looking at this over a year's worth of data, and in fact, it's very old data. So it's very old data across a really wide time range. And if I want to look at something like the average of this cluster of machines over that year-long time range, I can do so and have that data come back in a few seconds. That's pretty powerful. To be able to crunch a year's worth of data, it's not only a year's worth, but a really old time frame, and get the data back that fast is pretty cool. What's more is when you ingest data to Wavefront, it keeps the data that you send to it at its original resolution. That's actually pretty rare for systems like this. Most of the time, they will roll up over time. Like you might emit a new data point every minute. You might keep the minute data for a week. Then you might roll it up to a 10-minute average, to an hourly average. Maybe eventually you only have daily averages. It means if you're looking at historic data like this, you can no longer see the true original fidelity. In Wavefront, you can. If I look at the max of this, I can see that back in April in this year, this thing spiked up a lot. And if I drill into the spike, I can see how long this thing actually lasted for. It lasted for a little under 10 minutes. So I was able to see a spike in a year-long piece of data that lasted for less than 10 minutes and have that query come back in seconds. Simple, but very powerful.
No, that's amazing. That's really a fantastic thing. I'm glad I talked you into this webinar because I just for myself I've learned a lot and think this is an incredibly powerful tool. And I know you touched upon it earlier, and this is a SaaS offering, so a customer could just go to wavefront.com and sign up and start going right off the bat, can't they?
Thank you for reminding me. I did intend to mention that very thing. Yes, just go to wavefront.com, just click free trial. You don't even need to talk to anyone. If you just click the buttons, fill in your email, you'll get an automated email right away to get started. Trials last 30 days, and you will have the opportunity to work with an expert from the Wavefront team to help you get started and ask questions and so on.
Well, I highly recommend everybody at least try that free trial. I would assume, if once they get into this and see all this stuff that it can do, I couldn't see you canceling it. But absolutely amazing, Connor. I thank you very much for your time. I thank everybody for attending as well, both in the Zoom and on Twitch. And like I said, we'll put this up on YouTube afterwards. So if you are watching via YouTube, for sure, feel free to email, well, you could tweet at me at vcloudmatter. You could email us at cloudcs at vmware.com, and I can assure you that we can get you an answer. We'll be back tomorrow with another office hours at this exact same time. We have a future webinar coming up in a couple weeks around some of our partner provider stuff. And it'll be actually interesting. We have one coming up with Oracle. I wonder if we can get some kind of synergy there, showing Oracle deployments on VMC then being monitored. So that'd be interesting. But yeah, like I said, thank you very much for your time. I think this was a fantastic session that, like I said, I learned a lot, and there's a lot that I plan on going back with and leveraging myself and talking to my customers about how they can leverage this. I think it's a tremendous value, so very, very much appreciative. And with that, I'll end the call. Thank you very much.
All right. Thank you, everyone. Goodbye.